How to choose what framework, solution or tool to use when you want to build a desktop application. So first of all, you want to understand the motivation behind this decision. You want to really commit to building the software that will run on desktop, and you want to identify first of all why you want to do that. What is the motivation to build not a web application that will probably do the same job, but specifically a desktop application? Most probably the list of your reasoning will include access to the hardware and specific operations with the file system, or certain background jobs or tasks that you want to run on the device of the client or customer, or let's say on the target device. So you want to understand what is the target runtime for your application. Will it run on Linux-based devices? Will it run on macOS-based devices? Will it specifically run on Windows? This question will probably be one of the main questions after you ask yourself why you want to build a desktop application. And when you ask why you want to build a desktop application, you also want to challenge yourself and to ask again whether you specifically want to go through this path, because maybe the web application will be sufficient, and maybe a web application with some tweaks will be able to do the work that you think you might only achieve with the desktop application. But okay, at this point, you're completely aware you want to build a desktop application. And then you might want to ask, what are the runtimes again? And then the answer to this question will identify whether you are going to utilize the cross-platform or you are going to use the native tools and implement something platform-specific. And most probably in 2025, the expectations to the pace of development is so high, so you must probably go into work with the framework that will be, first of all, cross-platform, and second of all, will be with popular language that you can easily learn, or maybe you already have it on board. You most probably will end up with the web engine, or let's say browser engine, that will render your front end, and most probably you have only two options. It's either Chromium or a web view. And you most probably will use some front end, maybe written in React, and then some backend code, maybe written in Rust, or maybe written in Node.js, or in JavaScript in general, or in TypeScript. And so at this point you understand why you want to build and when it will run. So, and then at this point you are able to make a decision whether you are going to run implementation on some Electron-based solution or Tauri-based solution. I think that today two main competitors in the desktop implementation field is unfortunately not Dart, not anything else, but Tauri versus Electron. Tauri is a very optimized, highly efficient and performant thing that has a downside. You want to have two different languages on board. You want to understand Rust and you want to understand TypeScript or JavaScript. And well, with Electron you are actually going the same direction, because with Electron you might need to build a custom implementations for the libraries, and most probably the custom implementations will force you to use the native OS APIs, and you will end up in either C++ or Rust implementations, which are completely fine and they are expected. And actually it's a good thing, because you might utilize still C++ with combination of Electron, and you still can implement what you want in a more efficient way. If you think that implementation in Node.js is just very resourceful or very resource draining or not that efficient, you might do that in C++, and that's completely fine. If you want to go that way, you have that option. So when I have to make a decision whether I would like to run the application based on Tauri or I would like to run an application based on Electron, at the end of the day, I don't care about TypeScript or Rust. At the end of the day, I only care about business requirements and the complexity that will occur based on my choice. And we can take a specific example. If I want to build a not rocket science application that runs on a client device and doesn't have a certain specific, very unique requirements, and shouldn't be that, or let's say it should not be more optimized than Slack. And what does that mean? Okay, so for example, you have an application that eventually will either transmit sound, live sound, it will transmit a live video, or it will transmit a stream of data. If this is the case, you want to consider something more efficient, because if the device, when it will run, is not that performant, your application might lose the quality of connection and might lose the quality of streaming, and then it will just be a loss of satisfaction of the customer. And this is why I don't really like Teams, and this is why I don't really like Slack and Discord calls, because it really depends on a lot of things on the customer device, and some people with not that performant applications, they struggle to hear, struggle to listen, struggle to screen share. And maybe it's not a problem with the implementation details, maybe it's just a problem on their operational system. However, I'm not here to judge anything. I'm just saying, if I am to make a decision, I would make this decision. So if it's a streaming and I want to be very specific on performance, and I would go with Tauri too. And there is a reason for that. I really can do very highly optimized application. And you would argue and you could say that I can do the same with Electron. Yes, I can do that with Electron, but then I will end up in a lot of custom modules that I at the end of the day will probably write in Rust. And then I would still have two languages, but then I would have a limitation in the performance because I decided to use a Node.js runtime. And if I still at the end of the day is going to use Rust, then what's the point? And I'm saying this after experience with cross-platform development with Tauri 1, Tauri 2 and Electron. There are several applications that I've been part of the development team and contributed to their success, and I've worked with Electron and I worked with Tauri. And I would say that whatever you choose between Electron and Tauri, you can make it work. If Tauri runs on a certain small factor devices, not full-fledged PC. However, if you have a limiting environment that limits your performance on the device, you probably want to consider Tauri, because you will have a better experience running this, and you can reduce the requirements to the system significantly. If we take an example, if we take, for example, a mini PC. If we have a mini PC and we have a choice to do something not that complicated but relatively performant to the device, and we have a choice either Electron or Tauri, we're probably going to go with Tauri because it will be more performant. Or if we can agree that we base our choice on the performance requirements and complexity requirements, then we can safely choose between two most popular cross-platform frameworks, either Tauri or Electron. You make your choice. You can build a relatively small POC and you can check the performance, you can check the size of the bundle, you can check many things. They have and they share many similar aspects. You have to sign the application still, and you can sign it either locally on or in pipeline of GitHub. You can sign this towards Windows, Apple, or you can sign it towards Linux. So this is the typical things that you will apply for software development in terms of desktop. So whatever you choose, you most probably is going to accomplish your business requirements. However, the pace of development will depend on the complexity that you've chosen. And again, whatever we say, we assume that you either have an experience with a certain field or you have to hire that experience. And in terms of Tauri, you have to maintain two skill sets. You have to deal with some features of Rust that are not that transparent and welcoming to the newcomer, so there has to be a learning curve. For example, global variables in Rust. Yes, you can trick the system with global variables in Electron, but you cannot do that in Rust. So you have this trade-off. And to me, the simple thing is writing Electron, because that's very subjective. I know JavaScript much better than Rust. And this is very subjective thing, because I know JavaScript better than Rust. So for me, the trade-off between pace of development and performance of the application is clear. Like if I don't care about the performance of the application, and if I can offload these problems to the client, I will probably make this trade-off and offload that to the performance of their PC. That might be a case. This is what Slack did, this is what Discord does, and this is what, for example, Mongo Compass also did that. And then many years ago there was a conference when they stated that, look, they started to rewrite a lot of functionality in Rust, and the application started to be more and more performant, and this is a great thing. However, if in 2025 you're considering that you are going to start desktop implementation, you have to really value the benefits of each system. And yes, there is a way in native development, and by all means, if you know this, if you can do it, go ahead and do the native application. If you have the budget for that, do native application for every environment, because eventually it will be better for the user and it will be better for community, because all these applications that slow down our hardware is not good. So I cannot keep Slack, Teams, Discord, Notion all at once. I don't like this, because I feel that my 1,000 tabs in Chrome will lag if I do that. So I have to quit those applications if I don't use them. All right, so you made a choice. Now you want to go ahead and organize your work. You probably will have a question. All right, how do I do the testing if I don't have the customers? Because what you will end up, and this is news for someone, if you want to build the application for Windows, you want to have Windows runtime. If you want to build an application for macOS, you want to have a macOS runtime. And the same thing with Linux. You want to have a runtime where you can build it. So when you are building the application through the pipelines in GitHub, that's possible because you can create those environments and you can sign your application, you can build your application, that's all right. However, if you have a local environment and then you want to render or you want to build your application and then some features you want to use for Windows specifically, or you want to use some feature specifically for macOS, you cannot test the Windows feature and you cannot build the Windows feature on Mac device. For example, you want to consume the data from the hardware, and the hardware will use the interface of operational system and will give you the data. It will be OS API. So you will use the library that provides macOS API and you will use the library that provides Windows API. And you will write this in your, for example, Tauri or Electron as a different module. So in these modules, you will identify whether that should be what is the runtime, and based on the runtime, you will be able to action the code. So imagine through the implementation, you want to access the display, right? You want to access the display, or no, you want to make a screenshot of a window, right? And this is a simple functionality. You want just to make a screenshot of active window. In both environments, in Windows and macOS, you would probably do that differently. So you would identify the link to the window, then you will find the window, then we will identify whether the window is customer is in focus. Then you're going to probably go in to make the snapshot. So if you write the code once, it won't work in both platforms because Windows has its API and macOS has its API. So you probably write two different libraries to perform this action, and then you do the flip. You identify what is the runtime right now, and then you run the code. Well, actually no, and then you run the build, because you will make a build based on the runtime definition, so you don't include the code that might not run on the platform, obviously. So you identify the runtime on the build, and then you just build the application dedicatedly, specifically for the certain runtime, and then you're good to go. So just to make a link back, why I started to discuss this, because not everyone understands that if you are building a cross-platform application, you would need those platforms to run and test it. A solution for that might be AWS Workspace or whatever any other platform that can simulate a certain device for you. I didn't check recently. I don't remember if AWS can give you a possibility to simulate macOS. I hope they do. However, for example, if you are developing on the Mac and you want to test Windows, go ahead and implement Workspace in Windows, and you can deploy your application after being built to that place. So, okay, now you have your POC in Electron, for example, and then you have the pipeline that will build it. Okay, now you want to sign it. So for signing, you want to find the digital provider of the signage, and you want to use this sign or key to sign it. Like, it should be electronically signed, because otherwise you will end up in the alarms and security violations on the target devices, because the target devices will say, oh, this is unverified developer, we cannot install the application on this device. So you might want to take a time in advance, and 1 month before the planned release or 2 months before the planned release, you want to request those signing keys. Because why it's 1 or 2 months? Because it's challenging. Every company can get that. However, it would require just additional efforts. You want to provide a lot of details sometimes, because it's a very serious thing. If someone provides you a key or certificate to sign your application, it means that they're responsible for a lot of things. And when you're signing application, for example, with macOS, you are going through an authorization process, and while you're doing an authorization process, you're providing additional data about yourself. If you're an individual developer, you provide information and certificate about your individual development process. And then if you're a company, under company, you would have a developer account, which you provide information about the company and developer themselves. So the authorization process will include this data, and then at the end of the build, you will receive the signed application. Building is a challenging thing, so I suggest every time you finish your working cycle, you do the signage, and you do the building. So, and it's not just to test the features, it's also to test the whole process. The fact that you have built the application, it's a great success. So you built the application, and it was signed, this is already first point to stability. Now you don't need to test the stability of the application, you just only want to test the stability of the software that you wrote. So it means it will do the pre-designed actions. So to do that, you can or might use the workspaces. For example, you have implementation environment locally, you're implementing under macOS, your target device is Windows, then you take and you implement AWS workspace and deploy your latest release there, and you test the Windows version there. As soon as it's tested, then you can consider that, okay, it's all done, and now I can release it to public. There are many aspects of the software development for desktop that you can consider researching, and one of them is versioning, because it really depends. You might implement the firmware over-the-air updates, and you might deliver every release. And Electron and Tauri both have these features on board. You don't need to implement it yourself or manually. It's already in the box, and this is a great changing aspect, because if you do that development from scratch, this feature is not there, you want to implement it yourself. Well, actually a lot of features are not there if you're doing implementation from scratch. For example, rendering is not there, and this is a very challenging thing to do the rendering from scratch. So you might probably go with not fully native development, but using some framework. And Electron or Tauri is one of the choices I would consider an option for myself when I decide to do that, as I mentioned before, the reasoning why I want to do that. Okay, so at this point you have your application signed and you have it ready for release, and then what is the version of your application? And you say, okay, so it's 1.0.0, and then my next version will be minor version 1.0.1, and then you can consider for example firmware over the air, and you just deliver every development cycle, and you just release your application to your customers every 2 or 3 months or every month. Depends on the pace of development, depends on the backlog, on the planned changes. And what you will probably face is that the resources on testing will be very high, because it's not that predictable on every environment. So for example, you want to implement notification feature, like native OS notification features, for example in Electron. So in Windows, notification works differently, and they have a different view, and you can do that differently. And then you would have a choice: should I use a native OS notifications, or I should use my custom written in my framework of choice notifications? And the difference will be that in one case you're calling OS API, and in another case you're just rendering another window with capabilities of your application. To figure out how to test, you probably want to create an additional backend environment where you will handle all your data, API calls, and you will call it acceptance environment, or UAT environment, or ACC environment, or maybe even testing environment. It depends on your decisions on whether you want to have development environment, production environment, QA environment, how would you structure that. But what you want to do is that the device that you use for testing should be the closest possible device to the latest updated OS that you have. So you might find the errors and problems preliminary, because it's very difficult, and solutions are not ideal. And if there is a problem with the internet, people click on update application, and then it takes time to update the application. And sometimes the internet gets cut off and it doesn't work, and then it collapsed, and then they have to relaunch it. So there are multiple different problems that might occur during the upgrade, for example, or during the calls. And you want to be sure that this is a working prototype or working solution in the target environment. So yes, testing is a very big part. And if you are curious or interested in how to do the testing and how to organize the development cycle for desktop software, because it's completely different from the web implementation, I would love to make a video about that, sharing this knowledge.